Welcome to Earth Science with Ms. Collins. Today we're going to talk about plate boundaries. So the Earth's lithosphere is broken up into tectonic plates, which move slowly over time. We know that our continent was once a giant supercontinent called Pangaea because we have evidence now that the coastlines match up like a puzzle piece. So the continents, if you were to cut them all out and then move them close to each other, you could make them fit like a puzzle. We also know that the same fossils are found on different continents that have moved apart from each other, but they fit together if we cut them out. So we do know that we have evidence to support this. A plate boundary is where two tectonic plates meet. And today we're going to talk about three of those types: convergent, divergent, and transform. So for our middle school students, this is the standard we're going to be working on. For our high school students, all right, first we're going to begin with convergent boundaries. So we have two plates that are coming together with a lot of force, and usually one will go over the other. The plates are moving together, and it's how mountains are made. If two continental plates collide, we're of course going to have mountains. We may have some earthquake activity also. Some examples are the Himalayan mountains over to the right and the Appalachian Mountains close to where I live over on the left. Divergent boundary is next. So those plates are together and they're coming apart. The plates are moving apart, and this process makes rift valleys. So at a divergent boundary, we have two oceanic plates. That means it's in the bottom of the ocean pulling apart. This process is called sea floor spreading. And this was first proposed by Harry Hess in the 1960s. He proposed that hot magma is rising up. So we've got the seafloor and it's coming apart, and hot magma and rocks are coming up, and it's forming new land. Next is the transform boundary. So we have our plates together and they're moving beside each other. The plates are moving past each other, and it's very common to have earthquakes at transform boundary fault lines. So we have two plates moving past each other. They could be moving in the different directions, but it could be the same direction. But we will normally see this as at a transform fault. And so a common fault in the United States that we hear about a lot is the San Andreas Fault in California. And we do hear a lot on the news about earthquakes at that fault line. So Wilson is a geophysicist, and he really inspired advancement in plate tectonic theory. And he had some major concepts that he had published. And one was that we can have a hot spot where the heat from the mantle is coming up and it could form volcanic islands like Hawaii. He talked about how we have ridges and trenches, and without them, we're not really creating or destroying the crust. He proposed something called the Wilson cycle, and that explains the origin of Appalachian mountains, for example, where you have a splitting of the supercontinent, but of course the Pangea is coming apart. The ocean basin on the bottom of the ocean is opening up, letting out the new land, the new rocks and magma. It closes up, and then we have a collision of those plates. So let's review. We have three tectonic boundaries types. We have transform, convergent, and divergent. So to help us remember today, our first task is going to be to draw the 3 types of boundaries. So go ahead and gather a piece of paper and let's write the name of the plate type and draw the arrows. So it doesn't have to be perfect. Don't worry, you can just use your arrows. So for transform, those arrows are going different directions. For convergent, the arrows are coming together. And for divergent, they're going apart. And if you need to pause this video, that's fine. All right, for task 2, we're going to use our hands. Get your hands. Let's wake our hands up. We're going to demonstrate those 3 types, saying the type out loud as we go. We're going to begin with convergence. We've got our hands up. We're going to now, those 2 plates are going to come together. They're colliding. And of course, the crust is going to be destroyed. And one is going to probably go over the other because of the force. So go ahead and demonstrate it yourself with your hands. You got convergent coming together. One is sliding up over the other, creating a mountain. Divergent. So the plates are together, they're coming apart, and that is how new crust is being created. So let's just think about the bottom of the seafloor, and as we have that mid-ocean ridge opening up, magma's coming out, rock is coming out, new rock, and it's creating new land. Transform boundary. We have our plates, and they're moving past each other with a lot of force, right? And so this is where we're going to have earthquakes. All right, for our third task today, we're going to demonstrate the types using a little mini lab of jelly and graham crackers. And you can try this at home or at school with whatever you have. You might just have some saltines and you're going to put them in icing. I've seen students put saltine crackers after lunch on top of ketchup. That's fine too. All right, so let me show you my lab here. Here we go. So we're going to practice, and I'm going to demonstrate it, and you're going to say the type of boundary. So we have 2 plates that are crashing into each other, and one is going to go over the other, making a mountain. What would this be? Convergent. Good. Good job. All right. Now we have 2 plates together, and they're coming apart. They're moving apart from each other, making a rift valley. What would that be? Divergent. Good. Good job. All right. Last one. You've got 2 plates, and they're really rubbing against each other, causing a lot of damage. What would that be? Transform. Right. Good job. All right, so now let's review together. A rift valley is evidence of what kind of plate boundary? What do you think? Divergent. At what type of plate boundary are most high continental mountains formed? The key word is mountains. Convergent. Good job. One more. What type of plate boundary is in the Southern California region? Transform boundary. Good job. All right, if you're looking for additional fun, you could make an infographic. You could use Oreos. You're drawing the crust, the upper mantle, the mantle, the outer core, inner core. You're making an infographic to teach whoever, maybe it's a friend or a family member, about plate tectonics. Then you're going to draw a divergent boundary coming apart using that Oreo to pull it apart and show them. You've got the convergent boundary, you're drawing a mountain that's appearing, and you're going to demonstrate it with the Oreo. And then we got the transform. Oh, look, that Oreo cookie is broken because this is normally when we see earthquakes. If you're looking for additional practice, if you click this link and go to Quizlet.com, you'll be able to do some flashcards that I've created over this slideshow. And then when you're ready, you can go to Quizlet and take the test. So if you're in need of any other science classes or lessons, let me know. I can be reached at sciencewithmisscollins.com or you can email me directly. Thank you again. Bye.